Welcome to EDU World Space.
For this problem on the topic of gravitation, we want to know what orbital speed must be given to a satellite in order for it to be in a circular orbit 780 kilometers above the surface of the Earth. We also want to know the period of this orbit. Now, we will apply Newton's second law to the motion of the satellite and obtain an equation that relates the orbital speed v to the orbital radius r. Now we can see the radius of the orbit is r, which is h plus re. Now, h is the altitude of the satellite, or the height above the surface of the Earth, and re is the radius of the Earth. So r is equal to h plus re. Now we know that it is a height of 760 kilometers, or 7.8 times 10 to the 3 meters, plus the radius of the Earth, which is 6.38 times 10 to the 6 meters. So the distance of the satellite to the center of the Earth, at which point the mass is located, so we assume the mass is all concentrated at the center of the Earth, and this distance r is 7.16 times 10 to the 6 meters. Now we know that if we take the sum of all the forces, and we'll call our vertical direction y in the diagram, the sum of all the forces in the y direction must equal to m times the acceleration of the satellite in the y direction. Now, the forces in the y direction is due to gravity, so Fg is equal to the mass of the satellite m times its radial acceleration. Now we know this force can be written as g, m the mass of the satellite, times the mass of Earth, me, over the distance r squared, where r squared is the distance from the satellite to the center of the Earth. And for the centrifugal motion, this is equal to mv squared over r, since the orbit is circular. So if we rearrange this equation, we can see the masses cancel, and we are left with the orbital speed of the satellite v to be the square root of the gravitational constant g times the mass of the Earth over the distance r. And all of these are known, so we can find this orbital speed. So this is the square root of g, which is 6.673 times 10 to the minus 11 in SI units, which is Newton meter squared per kg squared, multiplied by the mass of the Earth, which we know is 5.97 times 10 to the 24 kg, all divided by the distance from the satellite to the center of the Earth, which is 7.16 times 10 to the power 6 meters. And so calculating, we get the orbital speed of the satellite to be 7.46 times 10 to the power 3 meters per second. So that's the speed that the satellite needs to be given in order to stay at an orbital height of 780 kilometers above the surface of the Earth. Now in part B, we want to calculate the period of this orbit. So we know the period of the circular orbit is equal to the distance of one orbit, which is 2 pi r, over the speed v. And so this is 2 pi times 7.16 times 10 to the 6 meters, divided by the speed v, which is 7.46 times 10 to the 3 meters per second. And so calculating, we get the period of one orbit of the satellite to be 6,030 seconds, which is approximately 1.68 hours.